Are you a data scientist? Do your tools make it easy to track your experiments, deploy to a machine learning model to production, and manage a GPU cluster? This free book from O'Reilly can teach you how to do all that. It's about tuning neural nets, making them scale, and then deploying them to the real world.
Speaker is Siraj. He's a renowned data scientist, YouTube content creator, teacher, MOOC course instructor. I think a lot of you have tried the deep learning course already. He has a mission to inspire and educate developers to build AI. He's also a dApp developer and entrepreneur, founder of a crowdfunding platform for developers called Habi. He developed several iOS apps, including Meetup, and then has worked on a host of open source work. Besides that, he likes to travel, he's a musician, postmodernist, and scuba diver. And then I was tempted to say hello world, something, but I think I'll leave that to, so let's put our hands together and welcome.
Thank you. All right, hi everybody. All right, testing 4876. That's the next code for Bitcoin, so buy it at that price. No, I'm just kidding. Okay, yeah, you know, the end of that description was like this really old description that O'Reilly wrote when I wrote the book Decentralized Applications like 4 years ago, which at the time Hobby was, yes, a crowdsourcing platform that I helped create, but now it's deprecated and et cetera. You know how stuff moves in software. It's just like here and gone in like 30 seconds. But yeah, so this talk is called Decentralized. Let me move out of the way. Let me just get a feel for how this is going to work. Okay, Decentralized Artificial Intelligence. That's the name of this talk. It's really combining two technologies that are very hot today, deep learning and blockchain. We know about these two technologies, right? Even if you're in data science, you study blockchain at some point. There's articles. It's hard not to look at this space with some level of interest. So we're going to talk about how to combine these two technologies together to make something beautiful. So I want to start with a quote by a very well-known public figure, shall we say. The quote is, "He alone who owns the youth gains the future." And this is by Adolf Hitler. I just want you to think about this quote for a second. He alone who owns the youth gains the future. What did he mean by that? Clearly he knew what he was talking about. He was able to influence the youth to kill people by the hundreds of thousands. So I want to ask you guys this question. Who owns the youth? Single word answers. This is an open question. You can raise your hand. Who owns the youth? Facebook. Yeah. Facebook, okay. Really smart guy. Any other
Snapchat.
Okay, you guys know what's up. Yeah. Exactly. Yeah. Facebook, Snapchat, those are some possible answers. But let's talk about what the larger answer to this question is. Who owns the youth? Who owns the future? So in the 80s, the web was created, et cetera, right? The World Wide Web. We know that the web was created, but I remember going to CERN. CERN was in Geneva. I had a talk at CERN in Geneva, and it was amazing. Like the data scientists there, we were getting so technical. They knew exactly what was going on. Their questions were so beautifully orchestrated. They were challenging me. It was amazing. And those people, the amount of data that CERN has is amazing. Anyway, that's a tangent. When I was at CERN, I remember seeing Tim Berners-Lee's office, the creator of HTTP, the Hypertext Transfer Protocol for the World Wide Web. Arguably, without that protocol, everything that we're doing, Carousel, everything about the web wouldn't exist. And I remember seeing his office and just standing there for a second and being like, wow, this is where it all began. And then I backed up for a second and I was just like, oh my God. And all these kids started coming in. I was like, oh, I better back up. And these kids started coming in mass. And they were like, I don't know, 8 or 10 years old. It was like a school field trip. And they came in and they saw, and then the teacher was like, or the guide was like, and this is where the World Wide Web was created. And the kids were like, oh my God. And they took a Snapchat and immediately left. They didn't even, some of the kids just, when the guide said that, they just kept walking. So that's who owns the future, Snapchat. Right, because the kids use Snapchat. So that was Web 1.0. This man is Web 2.0. Who knows who this guy is? Just shout it out. Jeff Bezos. Who is the richest guy in the world right now? Jeff Bezos. Yeah. In '98, this was Jeff Bezos. He was selling books. That's all he wanted to do with Amazon.com. He was selling books. He had a very, very small office. His office was just a desk, right? And now Amazon is more powerful than Walmart. Its market cap is higher than Walmart. Its market cap is higher than any bookseller in the world, Barnes and Nobles, etc. All of these global brands, Amazon eats them up, literally, quite literally, Amazon acquires them. So Jeff Bezos owns Amazon. He's the largest shareholder in Amazon. And Amazon is just one example. We've got Snapchat, we've got Google, we've got Facebook. And these entities that we've created over time have been a result of entrepreneurs saying, how do we take Web 1.0 and how do we capitalize off of it? How do we create something where we can make money off of it? It makes sense, right? This is a beautiful technology, and the initial aims for the web were beautiful. They were very pure. Let's take this decentralized internet that Tim Berners-Lee helped create, and let's create services on top of it, right? So let me take the server, right? And instead of having all of these computers talk to each other, which was very hard to do at the time, let me just make one central server. Let me use this HTTP protocol to create this get and set transfer protocol and store all of that data on this central server, like that, right? And it made it easy to do things like have an Amazon, have an eBay, have a marketplace, have a social network, have a ride-sharing service. All this stuff that we use today is because we were able to create these centralized services. It worked really well, and there were no problems. In fact, it was a faster way to do things, right? It was a faster way, it was a more efficient way. It just worked. But what's happened now is really bad. Objectively speaking, this is not my opinion. It is objectively a bad thing. And this is not just coming from me. This is coming from the creators of the web. Tim Berners-Lee, Jerome Lanier, the pioneers of the internet, don't like what has happened today, what the internet has become. How do we fix this? What does Web 3.0 look like? Not Web 1.0 or 2.0, not having centralized services, but decentralized services. What the original vision for the web was to have decentralized services. In a good economy, we monetize more and more, but in a bad economy, we monetize less and less. What is the most valuable resource we have today? Can anyone answer that question? What is the most valuable resource that any person has today?
Knowledge.
Yes. Another word for knowledge is data. Data, exactly. But what are we doing with our data right now? We are giving it away for free in return for a free service, right? That's part of the terms of use for all of these services we use. Facebook's terms of service, Snapchat's terms of service. You let us use your data. We can learn from your data. We can profit off of your data. We can sell your data. And in return, we'll let you use a service. That's fine, right? It works. But what's happened is this is shrinking the economy because all of that data is being concentrated in these central servers, these connected cores that everybody has to connect through, right? These are gateways for the web. We need that data because as automation technology gets better and better, as we learn to automate all of these things, the only agency, the only power you're going to have in this new world that we're very fast moving to is your data. But right now you're giving it away for free. So what value do you bring to the world when you don't own your data? Nothing. Zero. You have no value. If you give away your data, you have no value. So you need to own your data and profit from your data, right? This is akin to something like a basic income. When robotics and automation technology and AI and deep learning and machine learning, when all of that gets good enough in the next 5 to 10 years probably, everything will be automated. Everything. Everything that can be automated will be automated. I just made that up on the spot. You call it my law. There's accountability as well, okay? So accountability is, we don't know what they're doing with our data, right? First of all, we want to own our data. We want to profit off of our data. Right now, we're giving it away for free, and they're doing something with it that we don't even know what it is. They don't have to tell us, right? They don't have to tell us what they're doing with our data. They could give it away to governments. They could use it to spy on people. I was having a conversation with a friend a few days ago, okay? We were talking about something, a single topic. Later on her phone, in the ad, it said the topic that we were talking about. They are listening on our phones. They are listening in real time. Facebook is listening. Our phones, they are listening to us. They are using that data because there are no checks and balances. That's just what's happened. They're so powerful. They're all around us. The Internet of Things is really a set of spy devices for these central authorities. And lastly, we are trying to solve AI. And I'm going to talk about that at the very, very end, but we're trying to solve AI, and we need a way to do that. And this is how we do that. All of these problems, a shrinking economy, data ownership, accountability, and towards general intelligence, all of that can be solved if we move to Web 3.0. So you guys with me? Like, we need to move to Web 3.0, right? This is the plan. How do we do this? So I'm going to tell you how to do this, okay? I'm going to tell you how to do this. I'm going to show you right now how to do this. You ready? Okay, here we go. It all starts with something very, very simple. The linked list. Who here has seen the linked list before? Awesome, yeah. Okay, so the linked list is a very, very simple data structure. I've got the code for it right here. Don't worry if you've never coded before, don't worry about it. It's only 12 lines of code. 12 single lines in Python. And what this does is it creates a data structure called a linked list. And a linked list is just a very simple object that's linked to the next object. That's linked to the next object. That's linked to the next object. And it just goes on as much as you want. And we can make one in Python. We'll just say class node. This is a class, this thing, this square. And let's give it some functions. Get data. Okay, that's going to give us what's inside of here, which is, if we could store it, the word hello. Get next. Get the next node in the list. Stack. Set data. What do I want to put in this thing? Hello, a number, an image, a video, whatever data. And set next. What's going to be the data in the next node in the linked list. That's it. This is a simple data structure. This is going to help us move towards Web 3.0. You might be thinking, wait a second, no, this has been around since the 80s. How is this going to help with anything? So let's take this linked list. Let's take this linked list, and let's store a copy of it on, let's say, 1 million computers. Let's just say, hey guys, I've got this linked list. I want you to store a copy of it. And inside of this linked list, we're not going to store the word hello. That does nothing for us. Let's instead store a transaction. And not just one transaction, several transactions. In fact, millions of transactions between people, payments. Let's store that. And let's try to make it so that no one can modify this linked list. No one can change the transactions in this linked list. How do we do that? Okay, what if we had a separate system of people, and all they did was they solved random mathematical problems with their computer, and this required a lot of computing power, like a lot. So much so that in order for you to be able to change any of the data in any of these nodes, you would have to have more than 50% of the computing power of all of those nodes that are solving these random mathematical problems. Now, what if the amount of computing power in those nodes was greater than the 500 fastest supercomputers in the world combined? Well, then you would have to have more computing power than the 500 fastest supercomputers in the world combined to change the data in this linked list. What that means is no one could change the data in this linked list. So if we did that, we had a linked list that everybody stored a copy of, that no one could change the data in, we would call it a blockchain. And that's what the Bitcoin blockchain is. It's a glorified linked list. That's it. It's a glorified linked list. And instead of calling them links or nodes, we call them blocks. And the reason it's called a chain is because it's not just pointing to a random node with the word hello in it. It's pointing to a random node with transactions in it. And the reason that the transactions are stored as this tree, decision tree to be specific, we can call it a Merkle DAG as well, we don't have to talk about that, is because that's just a more efficient way of storing it and retrieving from it. But you can just think of it at an abstract level as just a list of transactions. And that's a blockchain. So this is a very new idea, right? This was 8, 9, 10 years ago when Satoshi invented this concept. It was the first time where we could say, I'm going to store my transactions in this data structure. That's what the blockchain is. It's a data structure. I'm going to store my data in this thing, and no one's going to be able to modify those transactions. That's why we use banks, right? There are only a few real banks in the world that we trust enough to store our money in, or something very valuable. Because we trust that they're not going to modify, essentially, the list of transactions in our account. They're not going to modify that. They're going to say, this is the amount you had before, and this is the amount you have now. Trust us, right? And that's it. We trust them. But what if we could store our money in a way that we didn't have to trust the bank, so there's not a third party? This is the first time that we've ever been able to do that, the advent of this data structure, right? That's cool, okay, we don't need a bank. Great, so what? What else could we store in this thing besides transactions? We don't need to trust a third party to store our transactions. We don't need to trust a third party to store our data. We don't need to trust a third party to store our code. What about our web apps? What about our apps like Snapchat and Facebook and Google? What if we could store code in this thing, not just transactions? And that is what Ethereum's blockchain is. They took Bitcoin's blockchain, they added a bunch of other data like logs, difficulty, timestamps, mixes, but really what matters is this, the code. You don't just store transactions in the Ethereum blockchain, you store code. What that means is every computer, every node, remember it's a glorified linked list, every node in the network is storing code. Instead of pushing code to a single server like Heroku, right, that's how we usually build web apps, we store it on a single node that everybody has to agree upon. So in order to modify that code, you would have to have more computing power than the 500 fastest supercomputers in the world combined. So this is a trustless way to build web apps, and that's how we're going to get to Web 3.0. So what does code on Ethereum look like? Go back. This 17-line of code snippet is what you would call an initial coin offering. 17 lines of code is responsible for raising more money in the past 2 years than have been raised by every IPO in the past 10. We're talking about more than 100 billion US dollars worth of investment from the public. Every ICO that you're seeing these days is a result of this. Someone takes this, adds a variable that says how many shares or coins or tokens do I want, and how much do I want to sell those tokens for. They take this code and they push it to the Ethereum blockchain via a push command in terminal, or they could do it via a web app. And then they have this public address, 25 characters or more. And they say, here's the address, ICO time, invest. And then people just, 30 million in a single day. This kind of stuff happens. This is very powerful. And no one controls this, right? This is the advent of a new structure, similar to a corporation, a new type of institution that no one controls. And we can do this with Ethereum's blockchain because we don't have to trust a third party. Not just a bank, but even a government, legal documents, things like that. We can build these with smart contracts. Things every time we've had to require to trust a third party, we can remove that and push that instead in the form of contracts to the Ethereum blockchain. There's a problem though. So if you think about, okay, well, I'm going to make a web app and it's going to pull from the weather.com API and it's just going to tell you the weather. That's it, okay? So it's called myweatherappdecentralized.com. And all it displays is a single text, the weather today in Singapore. And it pulls that data from weather.com's API with the parameter Singapore now. It returns the result and it displays that, right? Whatever degrees Celsius. If we were to do that on the Ethereum blockchain, it wouldn't work. Why? Because every single node in the network has to pull that data at the same time, right? Because they're all executing that code at the same time. But the weather changes over time, right? So they would all have to agree upon the time. How do you do that? You can't, right? So the solution to this is to have what's called an oracle. And the oracle is a trusted third-party source that speaks to the web that the Ethereum blockchain can pull from. So you might be thinking, wait a second, okay, I thought this was trustless. What is the deal with this oracle thing? There are networks of oracles out there, delegations, 4 or 5 of them, and they can all agree on, they can have consensus on some data. But this is a solution to pulling data from the Web 2.0 in the form of APIs until we have a better solution. But that's how it works right now.